Welcome. Okay, so we are still on dimension analysis. Let's consider the problem on the board. It says a sphere of radius r moving with a velocity v through a fluid experiences a retardation force F given by simply this. So this is the force F equals 6 r to the power of x v to the power of y, and okay, we'll have this to the power of z. That's actually unit of viscosity. Okay, that's mu. Okay, so where mu is the viscosity, okay, it's stated here. Where mu is the viscosity of the liquid. Question says use the method of dimension analysis to find the values of x, y, and z. So they are simply asking us to use the method of dimension analysis to find the values of x, y, and z. So in this equation, they've already given us the basic equation that we need. Of course, so from here now, the next thing to do is to find the dimension of all the variables, okay, that is involved. So first of all, we have force. Dimension of force, of course, you know that force is simply mass times gravity. And I've always said that the very best way to find the dimension of physical quantities is actually from their units. Now, the basic system of measurement we use is simply the MLT to find dimension analysis. So we'll have the MLT, where M stands for mass, L stands for length, which is unit of meters in terms of units, and T stands for time, that is seconds in terms of units. Okay. So to find the dimension of force, mass, of course, dimension of mass is simply capital M. We need to now find what is dimension of gravity. So the very best way to find dimension analysis is simply from their units. We know that acceleration due to gravity, g, is actually measured in meters per second squared. That's the unit of acceleration due to gravity. While meters is a unit of what? Length. And dimension of meters is simply what? Capital L from the MLT system. So this is simply what? Capital L all over second squared here. Seconds is a unit of time, and time is measured in capital T from dimension analysis. So we simply have here T, but since second is squared, it becomes T to the power of 2. So we have this. So I said that this can also be written as what? L into 1 all over T to the power of what? 2. We can simply have this. Of course, if you factorize L out, L multiplies by 1, c gives you L all over T squared. So you see the same thing. Now, this quantity 1 over T to the power of 2 can now be written as, okay, we can simply call the dimension of G to be equal to becomes L T to the power of minus 2. So simply converting this to what? Bar. Okay, so it becomes, since here is to the power of 2, it becomes to the power of minus 2. So this is the dimension of acceleration due to gravity. So that actually now implies that we can now find dimension of force to now be equal to, in place of mass, dimensioning of mass is simply capital M. We simply have capital M. And dimensioning of G, which is acceleration due to gravity, is simply what? LT to the power of minus 2. So we simply have LT to the power of minus 2. So this gives us a dimension of force. Next is to find dimension of radius. Of course, radius is measured in meters. The unit of radius, R, is actually what? In meters. And I said the very best way to find the dimension of physical variables is actually from their units. We know that meters is simply what? The unit for length. Okay? So which means dimension of radius R is actually what? Capital L. Okay? That signifies the unit meters. Okay? So simply capital L. And then we have viscosity mu, and of course the unit of viscosity once again is simply Newton seconds per meter squared. This is the unit of viscosity. So I said it is always best to find dimension of physical variables from their units. It gives the best results. It makes it easier for you. So the unit of viscosity is simply Newton seconds per meter squared, and you can simply have okay, viscosity is now equal to, we know, okay, let's take it here. Viscosity is now equal to, obtain the dimension now. We know that Newton stands for what? Dimension of force. Because this is Newton seconds per meter square. Newton stands for dimension of force. And dimension of force is obtained as MLT to the power of minus 2. So in place of Newton, we simply have MLT to the power of minus 2, okay, times, we have Newton seconds. Seconds is unit of time, and dimension of time is simply capital T. So we simply have times capital T all over, okay, Newton seconds per meter squared. Meter is the unit of length, which is capital L in terms of dimension. But here we have meter squared, so it simply becomes L squared, all over L squared. So we simply have this. And of course, if we critically look at this equation, we can find that the dimension analysis for viscosity is now equal to, this is M. So notice here that I have L and I have L to the power of 2 here. So one of these L can cancel one of this L. So I'm simply left it. Also, I have here T to the power of minus 2 times T. And from the law of indices, once two variables multiply each other having the same base, simply pick one of the base and add their powers. You agree with me here now that T here simply means T to the power of 1 is still the same thing as T. Okay, so I will simply have T, pick one of the T's and add the powers. The power here is minus 2 plus the power here is simply what? 1 all over. Not forgetting, L here cancel one of these L. So I'm left here with simply what? L. So one of the L's is gone. Okay, so this is now equal to, this becomes M. Okay, so T. So from here, minus 2 plus 1 simply gives us minus 1 all over L. Okay, so the dimension of viscosity is now equal to, so let's factorize now. We can simply bring out mt to the power of minus 1 into, this becomes 1 all over L. Okay, we simply have this, of course, factorizing mt to the power of minus 1. If this multiplies 1, we still have the same equation. Okay, so by indices, we can now simply write 1 over L to simply be what? L to the power of minus 1. So if we rearrange the equation, we simply have this to be M L to the power of minus 1, that is this now, then T to the power of minus 1. So this becomes the dimension of viscosity. So that is the very first thing to do, obtain the dimension of all the quantities. Okay, next we'll have velocity, not forgetting, we'll have velocity there, and okay, pull it out. I've always told you the best way to obtain dimension of physical variables is simply from their units. We know that velocity is measured in meter per seconds, which is a unit. So velocity is simply what? Meter per seconds. That's the unit of velocity. Okay. So this actually implies that velocity itself is now, in terms of dimension, meters is unit of length, which is simply what? Capital L. So we simply have capital L all over seconds is unit of time, which is capital T in terms of dimension, all over capital T. So we have this. Okay, so we can basically rewrite the equation and we are going to obtain. All right, so of course, if we factorize L, we simply have that V is equal to L into 1 all over T. And if we write this equation, we're going to obtain that the dimension of velocity is now equal to L. Of course, 1 over T is same thing as saying T to the power of minus 1. So this becomes the dimension of velocity. All right, so again, please take note. We also have 6 in the equation, in the fundamental equation. Let me pick it out here. We have fundamental equation F equals 6 r to the power of x, v to the power of y, and rho to the power of z. Now, 6 is a dimensionless quantity. 6 is dimensionless. It doesn't have a unit. Okay, so which means we can liken 6 to be equal to what? 1. It's a constant. So you have to actually take it off from what? Equation. You can liken 6 to be equal to 1 because it's a constant. It's a dimensionless quantity. It doesn't have a unit. So you can liken 6 to be 1. So 6 has to be taken away from this equation. Therefore, the fundamental equation becomes F equals, this is now r to the power of x, v to the power of y, rho to the power of z. And we've obtained the dimension of all the quantities here. We can now represent them in the equation. So simply represent all the dimensions. F for force, we obtain the dimension of force as simply M L T minus 2. Okay, and this is equal to, then we obtain dimension for radius as simply what? L, not forgetting radius is to the power of x, so it becomes L to the power of x times, we obtain dimension for velocity as simply L, LT to the power of minus 1, okay, not forgetting to the power of y here, raised to the power of y, and then we obtain the dimension of viscosity as simply ml to the power of minus 1 t to the power of minus 1. So we simply have a m l minus 1 t minus 1, not forgetting l to the power of z. So you have this. Okay. So bringing this down now, we have m L t to the power of minus 2 is now equal to, next is to expand the brackets with their given powers. So we have here L to the power of x, okay, times L here to the power of y becomes L to the power of y. T minus 1 to the power of y will now simply give us minus 1 times y. That simply gives us t to the power of minus y, okay, times, here we have m times z. Okay, well, that simply gives us m to the power of z. Okay, we have here L minus 1 at the power here times z simply gives us minus z. We have t, same thing, minus 1 times z here simply gives us minus z. So you simply have this. Now, from here, of course, m can be written as simply m to the power of 1. L here can also be written as L to the power of 1. Okay, so if we do that, we'll simply have m to the power of 1, L to the power of 1, t to the power of minus 2 equal to, this equation is still the same thing as this, nothing changes, it's still the same. Any number to the power of 1 still remains that number. Therefore, any variable to the power of 1 still remains that variable. Now, since I have my left hand arranged in MLT system, I'm also going to make my right hand side of the equation to be arranged in MLT system. So the only thing we need to do now is to rearrange this equation on the right hand side. Let it be in terms of MLT. So we start with m. I have just one m here, and that m is raised to the power of z. So bring it first. You have m to the power of z times. Next is l. I have l here to the power of x. I also have l here to the power of y. I also have l here, okay, to the power of minus z. Okay, that's that for all the l. Next is to bring the t's together. I have t here to the power of minus y, so simply t to the power of minus y. I also have t here to the power of minus z. Okay, simply t to the power of minus z. So just to rearrange the equation in terms of m, l, t. Okay, so we can now proceed. Let's move over to the other side of the board. All right, so just to continue from where we stopped, so we simply have m to the power of 1, l to the power of 1, and then t to the power of minus 2. And I said, simply write this side of the equation to be in forms of m, l, and t. All right, so we have here m to the power of 1, l to the power of 1, t to the power of minus 2, and this is equal to, so we have only m here, put this down, m to the power of z. Now we have L to x, L to y, and L to the power of minus z here. And from the law of indices, when you have three variables or three variables multiplying each other, or two variables multiplying each other having the same base, all you need to do is simply pick one of the variable and add their powers together. Now we have Lx, Ly, and Lz multiplying each other. They all have the same base. So you simply pick one of the base L and add the power. So power here is simply x plus power here is y, and power here is simply minus z. So you put that down, and then finally you have the same thing here. You have two variables multiplying each other. Pick one of the base, which is t, and add the power. So you have here minus y minus z. So you have seen that we have been able to transpose this equation now in forms of MLT, just like we have on the left hand side MLT. So now having known this now, the next thing to employ is what we call the principle of dimensional homogeneity. And what does the principle say? It simply says, let the powers of each of the variables on the left hand side of the equation be equal to the powers of each of the variables on the right hand side of the equation. So simply for m, okay, the power of m on the left hand side is simply 1. I have this power here to be 1, and this is equal to the power of m on this side of the equation is simply z. So call this equation 1. Same thing for l. The power of l on this side is simply what? 1. So you simply have 1 is equal to the power of l on this side of the equation is simply x plus y minus z. Simply call this equation 2. And finally, for t, the power of t on this side of the equation for t, the power of t here is simply minus 2, and minus 2 is simply equal to the power of t on this side of the equation. We have here minus y minus z. So put that down, minus y minus z. Call this equation 3. So we've already obtained from equation 1 that z itself is equal to what? 1. We've already established here that z is equal to 1 from equation 1. So all we need to do now is simply substitute this value for z into equation 3 to find the value of what? Y. So substitute z equals 1 into equation 3. So if we do that from equation 3, we simply have here minus 2 is equal to, we have minus y minus the value of z is 1. So in place of z, we simply put the value as 1. Okay. So you simply have, to make y subject, let's simply send minus 1 over to this side of the equation. So we simply have minus 2, negative sign, constant equal to sign becomes positive. So we have plus 1 is now equal to minus y. Okay, we have this. Okay, so we have this. So from here, minus y is now equal to, of course, minus 2 plus 1 simply gives us minus 1. So from here, negative can actually cancel negative. So this actually implies that y itself is actually what? 1. So we've obtained the value for y is equal to 1. If we know y, all we need to do is simply substitute y and z into equation 3, equation 2, because we have the value for y now, we have the value for z. So simply substitute into equation 2 to find the value for x. Alright, so substitute y equal to 1, z equal to 1 into equation 2. And if we do that from 2, we are simply going to have, okay, from equation 2, we simply have here 1 is equal to, this 1 equal to, we have x unknown, x plus y, but y is actually what? 1. So it becomes x plus 1 minus z, and z itself is actually what? 1. Alright, so 1. So this simply implies that 1 is equal to x. 1 minus 1 simply gives us what? 0. So this implies that x itself is actually equal to what? 1. And the equation says we should use the principle of dimension analysis to obtain the values of x, y, and z. So simply x is equal to 1, y is equal to z, sorry, y is equal to 1, and z is equal to 1. So these are the values of x, y, and z. Alright guys, I hope you find this video very interesting and helpful. Please, if you do, I would like to get your thoughts in the comment section. And of course, if you're new to the channel, don't forget to hit the subscribe button. I will see you in the next video with more questions on dimension analysis. Thanks and cheers.